Good morning. In this session, I am going to explain you some more problems based on the topic work power energy given in previous JEE main. Let's move on to the problems. Actually, we have completed 65 problems in the topic work power energy given in previous JEE main. Let me continue with the problem number 66. Read the problem carefully. A particle is released from height S above the surface of earth. Okay, at a certain height, kinetic energy is 3 times potential energy, height from the surface of earth and speed of the particle at that instant respectively. So, let me note down the data. A body is released from a height S from the ground level. On reaching a point P, its kinetic energy is 3 times potential energy. So, at P, kinetic energy potential energy ratio is given as 3:1. Kinetic energy is given as 3 times the potential energy at that point. So, here I will tell you a very interesting shortcut method. So, what is asked here? What is the height of the point P? Let us take this as height h. You need to find out h. And also, what is the velocity of the body at that point P? Here the data given is 2 things. It is released from a point which is at a height S, and at the point P, KE/PE ratio is 3:1. If KE/PE ratio is 3:1, total energy is 4 parts. So, at the highest point, total energy is in the form of potential energy, that is equal to mgs. From law of conservation of energy, total energy is constant everywhere in its journey. At the highest point, it is in the form of potential energy. At the lowest point, it will be in the form of kinetic energy. At any point on its way, it is in the form of both Ke and Pe here. Now, at this point P, potential energy is 1 part out of 4 parts. So, total potential energy at that point is mgh, that is equal to 1/4, because it is 1 part out of 4 parts, 1/4 of the total energy at that point. As total energy is constant everywhere, highest point potential energy is the total energy everywhere. So, if you cancel mg here, so height of the point is S/4. So, height of the point is S/4. One answer is done. You have to find the speed of the particle at that point. Here, see, if speed is v, kinetic energy is half mv square. It is given that kinetic energy is 3 parts out of 4 parts. So, 3/4 of total energy, that is mgs. So, m and m gets cancelled, this gets cancelled twice. So, v square is equal to 3/2 gs, or v is equal to square root of 3/2 gs. So, the perfect answer is height of that point where Ke is 3 times potential energy is S/4, and at that point velocity is square root of 3/2 gs. Go to the next problem. A stone tied to a string of length L is whirled in a vertical circle, and the other end of the string is at the center. At a certain instant of time, that stone is at the lowest point and has a speed u. The magnitude of change in velocity as it reaches where the string is horizontal. So, a stone tied to a string is whirled in a vertical circle with one end of the string at the center. At the lowest point, velocity is tangential all the time. So, at the lowest point, velocity is horizontal. When the string reaches the horizontal position, at that point velocity is along the vertical direction. You are asked to find, as the stone moves from the point A to B, what is the change in velocity. Velocity is a vector. So, here there are two vectors u bar and v bar which are at right angles. So, change in velocity on travelling from the point A to B is square root of u square plus v square. When two vectors u bar and v bar are at right angles, the magnitude of their change is square root of u square plus v square. So, if you want to use this formula, you should find out the value of v at the point B. So, for that consider the journey from A to B. At the point A, initial velocity is u, A is equal to, as it is moving in the vertically upward direction, A is taken as minus g, S is equal to, that is the length of the string here is the radius. As the body moves from the point A to B, vertical shift in center of mass is nothing but the radius, that is given as length of the string here. What is velocity? So, as v square minus u square is 2as, if you substitute the given data here, what do we get? V square is equal to u square minus 2gl. So, if you substitute this here in this formula, change in velocity is square root of u square plus v square, that is u square minus 2gl. So, it is square root of 2u square minus 2gl. If you take the 2 as a common factor, 2 into u square minus gl, that is the change in velocity as it moves from the lowest position to the position where the string is horizontal. So, the answer is, see here, if you compare this to this one, okay, he has given x into u square minus gl, but we got it as 2 into u square minus gl. So, in place of x we got 2, the correct option for that is B. Okay, move on to the next. Look here, a body of mass m is dropped from a height b and it reaches the ground with a speed v is equal to 0.8 root gb. Okay, value of work done against air resistance or air friction. Work done against air resistance is lost energy. So, here actually when there is no air resistance, total energy is constant. At the highest point, total energy is in the form of potential energy. At the lowest point, total energy is in the form of kinetic energy. Lost energy becomes initial potential energy minus final kinetic energy. Kinetic energy half m v square. V is 0.8 root gb whole square. This is work done against friction, lost energy. So, this is mgb minus half m, if you square this 0.64 gb, right. So, if you take mgb as common factor, mgb, this gets cancelled 0.32 times 1 minus 0.32. So, 1 minus 0.32 is 0.68 mg into b. As this work is done against air resistance, we use the negative sign because there is that negative sign indicates there is loss in energy. So, answer is minus 0.68 mgb. In the options, the printing mistake is instead of taking b, he has taken the maximum height as h. So, the correct choice is minus 0.68 mgb. That is the right answer. Move on to the next. Look here. A particle moves in one dimension from rest under the influence of force as shown. The force displacement graph is as shown. The kinetic energy of the particle after it has travelled 3 meters. So, according to work energy theorem, work done by a constant resultant force is equal to the change in its kinetic energy. So, the work done is equal to the gain in kinetic energy in this particular problem. So, from force displacement graph, work done is given by the area bound by force displacement graph with displacement. So, here gain in kinetic energy is nothing but area of the graph. This is, the graph is like a trapezium here. Okay, we know area of a trapezium is half into height. Height is this. So, 3 minus 2, that is 1, into sum of the parallel sides. This is 2 and this side is 3. So, 2 plus 3. It is 5 by 2 or it is 2.5 joules. So, here work done or the gain in kinetic energy is given by the force displacement graph in that problem. Right? Now, let us go to the next problem. A block of mass m lying on a smooth horizontal surface attached to a massless spring of constant k. Other end of the spring is fixed. Here, the block is initially at rest in equilibrium position. If the block is pulled with a constant force, what is the maximum velocity, maximum possible velocity for the block? If you pull it with a force F, then the energy, the maximum possible energy stored in the spring is U is equal to half k x square. But we know k is equal to F by x, from which x is equal to F by k. If you substitute that here, half k F square by k square. So, energy stored, another expression in a spring is half F square by k. This is the suitable expression in this formula. So, here on applying a force, the maximum possible energy stored in the spring is F square by 2k. When the spring is in its compressed state or extended state, this is the maximum possible energy. When it has its natural length, then this entire energy will be converted into kinetic energy of the block attached to the spring. So, from that we can say half m v square, where v is the maximum speed of the block, that is equal to F square by 2k. 2 and 2 gets cancelled. V square is equal to F square by km, or V is equal to F by square root of km. So, F by square root of has given it as mk. So, F by square root of mk. Move on to the next. Look here. A bob of mass m is suspended at a point by a string of length L left to perform vertical circular motion. By applying initial velocity given to it is V0, the string becomes slackened. This is the most important word. The string just slackens at the point D, ratio of kinetic energy of the bob at the point B to C. See here. First, actually in the synopsis I explained you everything. You have the shortcut formula also. Just recall, let us recall what I explained in this case of vertical circular motion. When a stone tied to a string is whirled in a vertical circle, if it just slackens at the highest point, that is the minimum required speed, so that it just negotiates a vertical circular motion. So, here the critical speed, or in case of a body moving in a vertical circle with critical speed at any point making an angle theta, we derive the expression for velocity. So, this is the case of a body tied to a string whirled in a vertical circle revolving with critical speeds, that is a minimum required speed. Here that is hinted by saying the string just slackens on reaching the highest point D. That is possible when the body is negotiating vertical circle with critical speed. So, when the body is negotiating vertical circular motion with critical speed at any position making an angle theta with the vertical, the minimum required speed is V is equal to square root of GR into 3 plus 2 cos theta. So, if you do not remember this formula, go back to the derivation. Once again, it is there in your notes. So, V is equal to square root of GR into 3 plus 2 cos theta, that we know. Now, what is asked? Ratio of kinetic energies at B and C. So, kinetic energy is half mv square. So, that implies kinetic energy is proportional to V square. So, kinetic energy ratio at the point B to the kinetic energy at the point C is equal to VB square by VC square. VB square by VC square. So, from this expression, V square is equal to GR into 3 plus 2 cos theta. As GR is also constant, V square is proportional to 3 plus 2 cos theta. So, let us be careful here. Kinetic energy at the point B to kinetic energy at the point C. Ratio is 3 plus 2 cos theta at the point B, that is 60 degrees, divided by 3 plus 2 cos, at C it is 60 plus 60, 120 degrees, cos 120 degrees. So, 3 plus 2 into half by 3 plus 2 into minus half. Okay, that is 4 by 3 minus 1, 2. The answer is 2:1. So, that is the correct answer for that problem. Is it okay? So, here it is very simple. In case of a body moving in a vertical circular path with critical velocities, that is if it is just negotiating the vertical circle where the string is about to slacken at the highest point, then the formula for velocity at any position making an angle theta is square root of GR into 3 plus 2 cos theta. As kinetic energy is proportional to V square, kinetic energy is proportional to 3 plus 2 cos theta. From that we could solve the problem very easily. Move on to the next. Look here, this is looking like similar, let me check. A body of mass 100 grams is moving in a circular path of radius 2 meters on a vertical circle as shown. Velocity of the body at the point A is 10 meter per second. Ratio of its kinetic energies at B and C. See, look here, when a body travels in a vertical circular motion, see here, suppose this is the point A, this is the point B, making an angle theta. Here its velocity is u, this velocity is v. Let us take the radius as r here. So, if you consider the journey from A to B, u is equal to u, a is equal to minus g, s is equal to l into 1 minus cos theta, that is the vertical shift in the center of mass, and v is how much? So, as v square minus u square is equal to 2as, here v square is equal to u square minus 2gl into 1 minus cos theta. This is the expression for v square. In this case, you are supposed to find the ratio of kinetic energies at different positions. So, kinetic energy at B to kinetic energy at C is velocity at B square divided by velocity at C square. Using this formula, velocity at B is u square minus 2gl into 1 minus cos, this is 30 degrees, 1 minus cos 30 divided by this angle becomes 120 degrees, C 120 divided by u square minus 2gl into 1 minus cos 120. So, u square at this point velocity is given as 10 meter per second, 10 square is 100 minus 2, g is given as 10, length of the string is given as 2 meters. So, it is 2, 1 minus cos 30 is root 3 by 2, okay, 1 minus root 3 by 2 divided by 100 minus 2gl into 1 minus cos 120, minus of minus becomes half, cos 120 is minus half, minus of minus. So, let us simplify this, 100 minus 2 2s are 440, 1 minus it is 2 minus root 3 by 2 divided by 100 minus 40, 1 plus half is 3 by 2. So, this gets cancelled 20 times, this gets cancelled 20 times. So, here look, this becomes 100 minus 40, 100 minus 22s are 40, minus of minus becomes plus, 20 root 3 divided by 100 minus 20 into 3 is 60. So, here let me simplify this further. Okay. So, here 100 minus 40 is 60 plus 20 root 3 divided by 40. If you take 20 as common and cancel, you will be getting here 3 plus root 3 divided by 2. That is the ratio of kinetic energy at the points B and C. Okay. So, here this is the hint. Velocity at any point making an angle theta, in case of vertical circular motion, if its initial velocity is u, it is u square minus 2gl into 1 minus cos theta, that is the expression for v square. Okay. Move on to the next. Look here, it is an interesting problem. A bead of mass m slides without friction on a wall of vertical circular hoop of radius as shown. The bead moves under the combined action of gravity and massless spring constant K attached to the bottom of the hoop. Equilibrium length of the spring is R. Equilibrium length of the spring is given as R. If the bead is released from the top with 0 initial velocity, velocity of the bead when the length of the spring becomes R. Look here. So, here it has reached from this, it has travelled a vertical distance of R, say. So, here what are the energies being converted into the kinetic energy of the bead here, because you are supposed to find the velocity. So, on releasing the top, it has moved through a distance and the vertical distance is R here. So, the lost potential energy is mgr. And about the spring, natural length of the spring is given as r, but initially it is stretched so that its length is 2r. So, the extension created is r here, okay, 2r minus r here. So, the potential energy stored in the extended spring is half k r square. So, as the spring moves from the initial length of 2r to the natural length r, lost potential energy, gravitational potential energy plus lost spring energy is converted into the kinetic energy of the bead. So, from this expression, see, if you take 2 as LCM, 2 mgr plus kr square by 2 is equal to half mv square. So, half and half gets cancelled, from which v square is equal to 2 mgr plus kr square by m, or it is 2gr plus kr square by m. So, v becomes square root of this. So, search for the option, this is the right option, 2 square root of 2 rg plus kr square by m. So, the question is given in an interesting way, but the concept is so simple. So, the lost gravitational potential energy and the lost potential energy of the spring are converted into the kinetic energy of the bead as it moves from the point of 2r, the stretched spring condition, to its natural length r. So, mgr plus half kr square is half mv square. This is the idea. And look into the next problem. A body of mass m connected to a massless unstretchable string goes in a vertical circle of radius r under gravity g. other end of the string is fixed at the center of the circle. Velocity at the top is n root gr, n greater than 1, ratio of kinetic energy at the top and at the bottom. Look here, so this is a vertical circle, this is the lowest point, this is the highest point. See here, this velocity is u, this velocity is v, so v square minus u square is 2as here. Here as it moves from the point A to B, u is equal to u, a is equal to minus g, s is equal to, this height is 2r, if r is the radius, this becomes the diameter. 2r, v is how much? So, v square minus u square is equal to minus 4gr, minus 2g, in place of s we have taken 2r. So, from this v square, velocity at the highest point is u square minus 4gr. So, now what is asked? Ratio of kinetic energy at the bottom. So, ratio of kinetic energy at the bottom point is taken as A here, kinetic energy at A to kinetic energy at B is equal to u square by what is given? Velocity at the top is okay. So, here substituting this, v is velocity at the top is given as n root gr. So, u square minus 4gr is equal to n root gr, so n square gr. So, from it u square is equal to 4 plus n square gr. Okay. So, u square is that and v square is equal to n square gr. So, just if you substitute that here, kinetic energy of the body at the bottom, that is at A, that at the top, that is v square, highest point velocity is taken as v square. This is equal to u square is 4 plus n square gr, v square is just n square gr. So, gr and gr gets cancelled, it is 4 plus n square by n square. This is the correct option for that problem. Ratio of kinetic energies at the bottom and at the top. Now, look into this problem. A body of mass m slides from rest along a curve of vertical circle from the point A to the point B, velocity of the body at the point B. When it is at the point A, it is at rest, what is its velocity? Okay, u is equal to 0. So, let us take this as A, this as B. As it travels from the point A to the point B, u is equal to 0, A is equal to L, it is moving in the vertical, in the downward direction, A is equal to G, S is equal to L into 1 minus cos, this angle is 90 plus 35, cos 135. Okay. So, what is the velocity? As v square minus u square is equal to 2as, v square is equal to 2gl into 1 minus cos 135, or v is equal to square root of 2gl into 1 minus cos 135. So, let us substitute the data given. See here, it is square root of 2, g is given as 10 here, radius is given as 14, 1 minus cos 135 is minus 1 by root 2, minus of minus it becomes 1 by root 2. So, this is square root of 2 into 10 into 14 into root 2 plus 1 by root 2. See here, root 2 is given as 1.4 approx. So, this is 2 into 10 into 14, root 2 is given as 1.4 plus 1, 2.4 divided by 1.4. This gets cancelled 10 times, right. So, here it is how much? So 2.4. So 1 0 gets cancelled. 24 2s are 48. So it is 480 meter per second under root. But the values are given approximately. You know 22 square is 489. So square root of 480 is a bit less than 22. Look at the options. If you look here, it is 21.9. That is the closest option. Actually, square root of 480, if you approximately calculate, it will be 21.9. Right? Move on to the next. Look here. A block of mass lying on a smooth horizontal surface is attached to a spring of constant K. Other end of the spring is fixed. Block is initially at rest. Now block is pulled with a constant force F, maximum force. This problem is repeated, isn't it? Energy stored in that spring on applying a force F is F square by 2K. If that is totally converted into kinetic energy of that is half mv square. So V square is equal to F square by mk, or V is equal to F by square root of mk. This is the option. It's repeated as is. Now look here. A block of mass 5 kg is moving at a speed, compresses a spring 30 centimeters when its speed is halved. The spring constant of the spring will be, see here, a block of mass 0.5 kg is moving with a speed 12 meter per second, compresses a spring through a distance 30 centimeters when its speed is halved. The spring constant of the spring. When its speed is halved, its kinetic energy becomes 1/4. When its speed is halved, kinetic energy becomes 1/4. Then the lost kinetic energy becomes 3/4. And that lost kinetic energy is converted into the potential energy of the spring. Okay, so here if you just substitute, half gets cancelled, mass is given as 0.5 kg, velocity is given as 12, 12 square is 144 into 3 by 4. This is equal to K. It compresses the spring through a distance 30 centimeters, that is 0.3 into 0.3. So from this 4. So here K is equal to 0.5 into 36 into 3 divided by 0.3 into 0.3. Okay. So if you cancel one decimal, here you get 0 here. So 9 cancels 4 times. 4 3s 12 5 6 60, it is 600 Newton per meter, that is the spring constant. Okay. Now move to the next problem. Actually these two problems I explained you in the previous session. Somehow we have gone back. So I'll stop here for today. I'll continue in tomorrow's class with some more problems. Thank you and bye-bye.